Hi, everybody. Welcome to the podcast. This is Beyond the Grid. I'm Beth Rattner. I'm your host. Thank you so much for tuning in today. We have a very intelligent episode. Is it going to be like kids? Is it going to be that one day they're autonomous and they're going to be making, it's going to be making decisions on its own?
I hope not.
I like the concept of semi-matic or the human in the loop piece. Like that, I think we're going to see for quite some time.
For those of you who don't know me, I lead the impact team here at Endeavour, and we really do focus in on sustainability. We believe that data centers can actually change the story around sustainability, and that Endeavour is leading that charge. We live in a world of connected devices. Your phone can tell you how well you slept last night. It can tell you whether or not running is actually good for your knees or not. The same thing is true for data centers. We live in a time when PUE numbers and uptime is everything. And the real workhorse behind knowing that is data intelligence. Data intelligence is often the unsung hero behind the data center story. But today we're going to get a chance to sing the praises of two very special guests that we have today. We have Director of Technology and Operations, Jonathan Rodriguez, and Evan Metzner, who is the Global Development Lead for Endeavour as well. They work in a department called EdgedIQ. Welcome, Jonathan and Evan.
Hey, Beth. Hello.
Thanks for having us.
It's great to see you guys. Thank you for doing this with us.
It's an awesome setup here. Love it.
I feel like you're both part engineer, maybe biologist. Certainly, Evan's got a background in urban planning. Maybe just tell me a little bit about how you got here.
So I initially, my academic background is in economic development and history, actually. So I was planning on doing development work in the Middle East. And I kind of fell into urban planning, urban design, specifically focusing on public transportation because I wanted to tackle more actionable and more local problems. And that's ultimately what led me to Endeavour as well, is getting even more actionable, even more technical and hands-on with the technology itself at the earliest possible stage of the development cycle.
And then for me, my background is mechanical engineering. I got my bachelor's and master's in that. Did a thesis in cogeneration. Fun fact, I took a programming class in college and I'm like, I'm never going to program because I just didn't understand it. And it wasn't until I got into the real world that I'm like, oh, I can actually start solving problems with this. And so from there, I took that and went from engineering to a technologist. Had to work on people skills to improve my leadership thanks to some mentorship and coaching I got, and got me to where I am today. So.
Well, let's jump right in here. This concept of digital twins, which we're going to talk about today, which is really the same process that we use in when we get to monitor our own biometric devices or when you're monitoring a data center. Like that concept's been around for a long time, right? This goes back to when in the 1960s, NASA used it to monitor what was happening for Apollo 13, when the oxygen tanks shook and ultimately exploded. People in Houston knew at the same time as the astronauts did. So we have this moment where this technology has been around for 50 years. What is a digital twin? How is it different today than it was back then?
I think we got to start with defining what's a digital twin, right? Because I don't know about you, Evan, but I feel like it's thrown around a lot these days, especially with AI. And you hear these buzzwords, AI, IoT, digital twins. So maybe we do a little like throat clearing. And if you look at it, there's a group called Digital Twin Consortium. And they define a digital twin as a virtual representation of an object or a process that is synced to real time at a certain frequency and with fidelity. Meaning I have a telemetry type of information like time series, like temperature or state of an oxygen tank. And it's modeled in the context of, well, there's a tank in a field system or a life support system on a shuttle. And that's a digital twin. And from there, the challenge with it is, what do you do with it? And in NASA's case, it was monitoring. In engineering, it's to simulate. And so one of the things I like with the Digital Twins Consortium is they give you like 60 plus capabilities of all these things a digital twin could do. And it's up to you to really define what is it that your digital twin is tasked with doing.
So what is a digital twin in the context of EdgedIQ?
Great question. So we have to go back to the mission of Endeavour, right? We're making a dent in infrastructure at a global level. And so when we have a global portfolio, we have a saying we call MOMO. How do you manage, operate, monitor, and optimize a diverse infrastructure portfolio. We got to have time series data coming in from all our equipment so we know, like, hey, is it operating the way it should be? How do we make a better product based on maybe some design condition that we missed? And on top of that, when we make these big sustainability claims, we got to back that up. So that's how we use digital twins.
I love being able to back up sustainability claims. That's important to me.
Absolutely.
Are digital twins really only for physical infrastructure, or can you also apply it to social or economic infrastructure as well?
I always come at this issue from my background, which is in urban planning, urban studies. So in that field, digital twins, smart cities are often utilized, like getting a 3D model of a buildings, of sewage infrastructure, of rail, roads, et cetera. And then you can run simulations off of that. So in one way, that's very physical. You're modeling a building, you know where the buildings are located. If you're going to build something new, you know which buildings you have to knock down to replace it. On the other hand, it can be used in all sorts of economic and social modeling projects off of that data. So things like shading analyses when a new construction project is going up. Who is this going to affect? Is it going to cast a shadow over the park at what time of year? And that can feed into participatory planning models where the community can have more feedback, more precise feedback based on real world attributes.
That's fantastic. And actually that's really leads me nicely into the question I was going to ask you, which is there's a lot of data about the different waste streams that come out of a municipality. It could be food waste, it could be sewage waste, it could be plastic waste. One of the things we're trying to do at Endeavour is model industrial symbiosis, where those waste streams become the food for a data center, specifically in the form of energy, right? So what does it take to run a data center? We have PACT, which can crack methane and turn it into hydrogen, which can run a turbo cell, and that could end up leading to a cleaner and carbon negative system. Does data intelligence play a role in looking at all of the different waste streams in a region so that we can get really smart about what waste streams we tap into to run those data centers?
Yeah, sure. And it's possible that in some contexts that a single waste stream can't supply all of the energy that a data center needs. So for example, if we have PACT, maybe that can supply 60% of energy needs. And if we can tie that in with other municipal value streams or other sources of energy, then those two things can work in concert. But if they had to work on PACT alone, the process wouldn't work or wouldn't pencil.
There's a good, just to add like a little analogy here, Beth, that I like as Evan's talking about it. It's like we're talking about orchestrating. And you think about like let's ground it in who we are, right? As humans and biology, like IoT is your nervous system, right? So it's sensing all the parts of your body, the temperature in your skin, your kidney, your liver conditions, oxygen, CO2, and that information goes to the brain. And the brain has a data model of how that information is received and processed so you can do something. And that's what we're getting to now, right? Is being able to pull that out and get to that point of managing and orchestrating, getting to like homeostasis, if you wish, in an industrial standpoint setting.
You're speaking to my heart here, Jonathan. Like that's what's so fantastic. That's the goal. We are really trying to emulate biological systems with this work. And so what I'm hearing you say, both of you are saying, is that this intelligence element is just as important as the technology stack itself, and that we really have to be able to connect the two. Is that right?
Absolutely. Imagine you had like the best lungs because you were a runner, but there was no communication from that to the rest of the body.
No, that makes total sense. Let's talk about some specific examples of EdgedIQ. One of the ones that Jonathan, you told me about early on was the bank branches. And I'd love for you to just share that story again, or any of the stories that first popped to mind.
Yeah, the bank branch is an interesting one because it's a pure like HVAC problem. Like if you're in a Class A tower, like multiple stories, and your goal is to save money, it's like, all right, reduce the energy efficiency. And you have a facility team in the building that can run up and down, stay on top of all the information, and you're saving like 5-10%. And because it's a big building, that's thousands of dollars, which justifies a salary. And all of a sudden, if I get to like these standalone buildings, like a bank branch, retail, like shopping center, fast food, they're buildings with what, 3, 4,000, 5,000 square feet. I mean, I've gone to Starbucks. I never asked to see the facility guy because he's not there. They're serviced out of a hub where someone gets in a van and drives out and figures out what the issue is based on some uninformed information or feedback they get from the building and the occupants. And what we ended up realizing and using with IoT was, because it's cheap, let's deploy these sensors and these thermostat controls in a portfolio of bank branches. And we did 700 buildings coast to coast across all of Canada. And for this customer, like if you would approach that without IoT, the cost to send an engineer to save, a couple $100 doesn't justify it. But now using IoT, it equated to millions of dollars across 700 locations. It's crazy enough. The return on investments, just to throw some rough order of magnitudes, was around 3 years on energy savings. So, and that's partly because IoT has just lowered the entry barrier to get data to the hands of where it needs to be. Funny enough, we didn't stop at energy. We're like, hey, what about like operations? It costs more money to send a truck and like the van. You get stuck in rush hour. You get there. It's like, oh, that wasn't the issue. The person just didn't know how to use the thermostat. It's like, oops. And now you can do remote control. Once you factor that in, paybacks were like 8-9 months and basically a return on investment. And you can even extend that further. And what I would have loved to do is like, well, what's the avoided carbon by not getting in a van and driving to the site to figure out you didn't need to? Let's talk about like indoor air quality. How are we maintaining that? And we actually saw that in COVID. As COVID came along, like the building operations changed from being purely about like maintaining comfort to, you know what, I got to cycle air all the time. And because of the IoT installation, it made it super easy for this customer to just change settings and deploy it in a matter of hours nationwide.
So based on the example that you just gave, Jonathan, how does data come back into the Endeavour universe? Maybe get fed back into the development engineers to improve products?
Absolutely. It starts with operations, right? So we're a mission critical facility, right? So any information we can get to maintain our uptime and optimize that, like step one, get the operations team in there. And then as we continue for Endeavour to continue to deploy more data centers, more infrastructure, it's feeding that back into the products because we're going to pick up all these design conditions that, we may have not picked up the first time. And now we have insight. We have that moment in time that something happens, some event, whether it's an outage or a peak heating day. Like, you know what? Let's rewind and ask ourselves some of the questions. Are we overbuilding infrastructure? Are we underbuilding it? And let's tune it.
That's actually a really good segue into talking about virtual power plants. Is that something, Evan, did you want to maybe explain what a virtual power plant is and potentially the technology that we have that facilitates making that possible?
Yeah, sure. So at a high level, what a virtual power plant is it's a roll up of a bunch of different distributed technologies that are inside of existing, usually buildings. And what they allow you to do, something like a smart thermostat, is when there are high levels of grid stress or the grid is at a peak, you can increase the thermostat temperature by a couple of degrees to cut down your usage by some number of kilowatts. And that's a really small number for an individual house, of course, but spread out over 100 or 1,000 units, that can add up to a substantial amount of energy. And this shows you the power of the distributed kind of IoT technology, where there's no way that a single house would have access to this capacity to influence the grid or help stabilize the grid. But in mass, they can provide some substantial buffer.
That's fantastic. Is there a technology stack that we have that can make that possible?
Yeah, I think this ties into the mission critical aspect that Jonathan touched on, which is that coming from the data center industry where everything has to be mission critical day one, we can apply that same or similar technology stacks to our distributed infrastructure or distributed IoT within the coffee shops, within the bank branches. And that allows us to bring that data back in a consistent manner and be a good customer, a good partner to these grids and these energy aggregators that are participating in these VPPs.
I think to add to that, what's interesting is you think about the chaos in the grid, right? And it's because there's a misalignment of power generation and power consumption, right? So this concept of virtual power plants is helping you bring both into alignment. It's not so much about the technology necessarily and the means to do that, but to do that and line it up, you have to have good quality data models and information because those are split-second decisions that have to be made. And if you modeled something incorrectly, like let's take a data center and we think it's going to do one thing and it does the opposite, and you tell the grid to do something else, that doesn't end pretty well. That doesn't end well at all.
It feels like monitoring, the way you're describing it, would have been part of data centers from day one for Endeavour. Is that really how, was your department born the same day that Endeavour was born, or has it evolved over time?
It's evolved. I followed the Endeavour core team around for a bulk of my career, and we were doing digital twins in basically 2011, before like it became such a buzzword. And that was around like, hey, let's monitor all the information we can on the data center so we can deliver and make a better product. And so we've just iterated from there. And as technologies evolved, we gone from like 2011 was everything was on a desktop, then it became mobile. And now we're talking about APIs and interoperability. So, but the crux of it is still the same. You got to model the data center. You got to have a good fidelity understanding of the context for that time series data and then be able to act on it.
Thinking about how it's evolved so much since 2011 and projecting out 5 years or even 10 years, where do you see data intelligence, monitoring, IoT going?
Um, the buzzword now is AI. And it's AI, they say that, and it's great. Like, but the challenge is what's it grounded in? AI is like raising a kid. So I have 2 kids. I got a 1-year-old and a 3-year-old. And if I tell them, like, if I give them bad information, they start behaving badly, right? But if I train them well with good quality parenting or good quality data, I get a better output. And what's exciting now that's happening this year is now being able to roll out like LLMs and natural language processing on our data set to make it just even more and more accessible. So continuing to watch that technology evolve, but have the right information, the right data, so we can actually actuate and make good recommendations on that. I think that's the big thing to look out for the next few years is how we continue to adopt and evolve and use AI, and it's going to just continue to show the need for that good quality data.
I would add on to that, that not only are we building analytics on top of this data fabric, but we're building entire structures and products off of this. So once we make this data available, then, and we make it reliable, then people can build tool sets that were not possible beforehand, or if they were possible, they would have had to structure and build out this whole backend system to enable it. So you can almost think of it like the App Store, right? Where somebody could have built a web app for your iPhone, and maybe a couple people would have used it, but there was no backend infrastructure for someone to go out in the world and access it. But now once this data is here, this access point is here, people can build all sorts of amazing tools that you would never have thought of as the creator of the actual infrastructure.
Yeah. You're talking a lot about like foundational tech there, right? And at the end, it's not losing sight of like, we got to solve the business problems, right? Like at the end of the day, I have, there's a gentleman on our team and he has a great saying, like his job every day is to kill a spreadsheet, centralize the data and make it accessible to all. So it's foundational. So then to your point, someone can act on it and solve a business need or business problem of the day.
Is it going to be like kids? Is it going to be that one day they're autonomous and they're going to be making, it's going to be making decisions on its own?
I hope not.
I like the concept of semimatic or the human in the loop piece like that. I think we're going to see for quite some time. And I think we talk a bit about having human in the loop, like designing for that human in the loop piece, because there's, again, back to the beginning, like there's a level of fidelity, a level of trust we need to have with these systems. And the second, like it fails because it's not supervised, we lose all the trust in that. So trust is paramount in keeping humans in the loop to make sure like, yep, we're good, feeling good, let's keep going.
Not to mention the understanding of the system itself. The data can be totally correct, but if the person interpreting it is interpreting it incorrectly because it's not visualized easily or simply, or just because it's confusing data to begin with, then that also has the same net effect. So it's worth keeping in mind that experts are going to be required throughout this process, even if we assume the technology and the data works flawlessly.
So let me just do a quick follow-up question. 10 years from now, will there be more people working in your department or far less because it'll be all AI driven?
I think we'll actually have more. There's a need for collaboration. It's ironic. Like I'm realizing like one of the biggest things here that I personally had to grow on was my communication, because working with an operations team, I don't know all the answers. Might as well ask them. Working with designers, what do you want? And I think it makes it a little gray and cloudy, or like what the team is. The team ends up being the whole collective Endeavour organization. So I guess, yeah, we grow in.
Not to mention the needs always expand to fit the function. So as soon as we have spare capacity, 5 more projects crop up that maybe weren't worth it before, but if someone's free. So I think that's going to just keep inflating as the capacity increases.
So we killed 2 spreadsheets today, not 1.
Yeah.
What's something that you want people to know about what you do?
I think that one of the most important things about what we do is that it's really multidisciplinary or interdisciplinary, in that when we're modeling a data center structure, or we're integrating a new device in IoT, or we're helping with site selection, all of these things require a lot of domain knowledge and more than we're ever going to acquire on our own. So it's working with teams collaboratively and trying to get as much of their knowledge out and get as much of our knowledge about what we're trying to build to them so that we can communicate and build something together that's effective.
I concur on that one. Like the interdisciplinary is huge, and it really talks about collaborative spirit, the need to collaborate. It probably emphasizes what Endeavor's done so good, which is creating that collaborative culture in the group. It's actually, I was thinking about it just as you're talking, Evan, but it's ironic. Like we talk about building like AI and IoT and these digital twins so that we can access information readily, quickly. But in doing so, we have to like actually up our level of people-to-people communication to even build that. So it's a little ironic kind of seeing it come full circle. Like, yep, we're back to the same thing. Let's call someone, talk, understand their needs, and then add value to them.
Well, if collaboration is the key to the future, you two are the perfect example. I'm so excited about where you're taking EdgedIQ, Endeavour Edged in general. It's going to be a heck of a wild ride. So thank you both for being the first pair that we had on Beyond the Grid. It's been amazing to have you guys together.
Thanks for having us, Beth. Appreciate it.
It's been great. Thank you.